The next task we'll look at is very similar to one we did earlier in the course. When we first started working with linear equations, we looked at how to check an answer by substituting our value for x or y, whatever the variable was, back into the original equation. Now we're looking at systems of equations, and we have an x and a y. If there is a solution to the system, it's a place where the lines overlap, or where they intersect, rather. And we are particularly interested in consistent systems where there's one point. So what we want to do is find out how to decide if we got the right solution to a system of equations. And the key there is to substitute the values for x and y that we find into both of our original equations. Why do we need to do both equations? It is possible to make an error in the process and have a number that works in one of the equations but not the other one. So our example is the system 2x minus y equals 5 and negative x plus 7y equals 4. We're going to determine whether either of these ordered pairs is a solution. Our choices are 3, 1 and 2, negative 1. The way we'll do this is by substituting and evaluating our result. So we're going to start with 3, 1. Here's our system again. And everywhere we have an x, we will substitute a 3. Everywhere we have a y, we'll substitute a 1. And I'll actually write this out rather than just making little red notes. 2 times 3 minus 1, is that equal to 5? Well, we have here a 6 minus 1. We have a 6 minus 1. And the question is whether that equals 5. 5 equals 5. So far, so good. Let's look at the second equation then. A negative of 3 plus 7 times 1, is that equal to 4? Well, a negative 3 plus 7, is that equal to 4? 4 equals 4, yes. Both equations checked out. So we can say that 3, 1 is a solution to this system of equations. Since these lines have different slopes, check with the negative a over b, or the slope-intercept form, we can be pretty sure that the next candidate is not a solution. But we're going to work through it so that you can see how to check your work and what happens oftentimes if you make a little error somewhere in the middle. So again, we'll replace x with, in this case, a 2. And y is going to be replaced with negative 1. And we have 2 times 2 minus a negative 1. The question is whether that's equal to 5. 4 plus 1 equals 5. Yeah, that looks good. And oftentimes I see people check their work and they don't do both equations. And so they think, oh, I'm good. But you have to check both equations because this might happen. A negative of 2 plus a 7 times negative 1, is that equal to 4? Negative 2 minus 7, negative 9 is not equal to 4. So we can see that 2, negative 1 was not a solution. And again, by checking in both equations, we successfully determine that 3, 1 is the solution. And that's the end of this example.